Hello learners, welcome to Tarek. Today we will be learning about the Lambda expressions and functional programming. So let's begin with asking what is this functional programming? In functional programming, we treat functions as first-class citizens. That means we can do things with the functions that we normally do with data. We can pass them as argument to other functions and return them from functions or assign them to a variable. Java historically was object-oriented language, focused on classes and objects. But starting with Java 8, the language adopted key functional features to let us write more concise, decorative, and readable code. The features include Lambda expressions. These features include Lambda expressions. These here they are anonymous functions which we can pass around. And coming further, we have the functional interfaces also. These interfaces with a single abstract method that Lambda can implement. These faces are with a single abstract method that Lambda can implement. And now the Stream API. This Stream API, a fluent functional style way to process sequences of data. So our goal today is to see how Lambda and functional interfaces let us write code that focuses on what we want to do rather on how we want to do. So we have coming here, we have the introduction to Lambda expression. So what is this Lambda expressions? Exactly what it is. Similarly, likewise we put the functional programming. Similarly, put a Lambda expression in anonymous functions. It's a block of code in parameters and a body. I repeat, it's a block of code with parameters and a body, but no name. We can think of this like a mini project. We can hand to other APIs, which we can hand to other APIs. Coming here, we have the expressions, we have the parameters that will be passed to the body part. We have the different parameters. We have the syntax of the Lambda expressions. It says that we have the body part. We have the parameters. We have the parameters which will be passed to different body parts. Yeah. Now moving further here. Coming on to example. Here coming on to example, we have the parameters int x and int y. These are the parameters. These are the parameters that will be passed to the body part. That will pass to the body part as return of x plus y. Return x plus y. This is the body part. Inside the curly braces we write the body part, and inside the body part the functions as returned as x return x plus y. The function will be returned as x plus y. Now a plus b, a comma b in the parentheses. This is the body part. A comma b in the parentheses in the body part, and which will be sent to a into b. A and b. This will be sent for the operations as a and b. And system.out.println. Here inside this parenthesis states that system.out.println hello from Lambda. This parenthesis states that system.out.println hello from Lambda. There is no return, no braces. Here, if the body is a single expression, likewise here the body is a simple single expression. Here also the body is a single expression. Here also the body is single expression. Here also the body is of single expression. So we don't need braces. So we don't need there is no return, and no braces needed. Yeah. Now this functional interfaces. Now coming on to this functional interfaces, Lambda do not float around on its own. Lambda do not float around its own. They must implement a functional interface, which is simply an interface with one abstract method. It's simply an interface with one abstract method. That single method is signature determines the Lambda. This single method is signature determines the Lambda parameter, list, and return type. I repeat, that single method's single method signature determines the Lambda's parameters, list, and return type. Here there are eight ships with a set of single purpose functional interfaces in Java util.function, Java util, java.util.function package. Here and there as follows. here, coming on to here, we have the first as predicate in the Angular basis relating T. This is a collection of interfaces and classes. This is a collection of interfaces and classes. But here this is a collection of predicates. And the method is test. Here the method provided is test. It which is a Boolean type. And so it will return a Boolean value. It evaluates a Boolean condition. It will evaluate a Boolean condition. Now the function with the parameters as tr. Uh, it applies to t and t. It applies to t, yeah, and transform a t to into r. Converts to r, and it transforms t to r. T comma t. You can write it as t. It applies to t and has object as t. Yeah. Now it converts the t into r. Now coming on further, we have the consumer, which has the function t. It has concept t, void concept t, void concept t, and t also. Yeah. It takes t and return nothing. It takes that value of t, it takes the value of t and returns nothing. There is no return type. Yeah. Now supplier t. Here t gets t. Here small t, capital T, yeah, capital T gets t, the value of t, yeah, and return t without any input. It return a t. It will return a t, and without any inputs, and taking nothing with no input, without any input. Now coming further, why we use this lambda? Now coming further, we have the example also, because the example here first. Yeah. So for the example, we will be watching out here that there is a basic example. This is a basic example. Yeah. Remember runnable R is a function which has a body part, will be printing system.out.println running in thread. This will be printing running in thread. Now thread R, now new thread R dot start. We are putting this thread to start. And now custom function. There it follows to the custom function interface. Now the function add the rate of functional interfaces like annotation. Here we have add the rate of functional interface calculator. Here there is an interface calculator. That here we have a method called interface calculator, which has a body part int compute a and b. Int compute, we have to compute the value of a and b. We are passing the parameters here a and b, and following that parameters we have the lambda, we have the public class demo, which has the main method line, following the public static void main string args. And now the calculator add. There is a calculator add. To this add variable, we are passing the value of a and b. As a parameter, and they are passed to a body part, right? These parameters will be passed to these parameters will be acting as parameters, and they will pass to a body part, which will be stating that a plus b, and finally we will be having the operations will be coming to the system.out.println compute add.compute. We will be having add.compute. To this add variable, we will be assigning the value of compute. Now we will be assigning the value of compute. To this add variable, we will be assigning the value of compute a and b. Yeah. So compute a and b, where we are passing a and b parameters as 5 and 3. This a and b when coming here, with this a and b when coming here, when they will come here, 5 and 3 will come here, they will have a body part where it says that body will be having operations on that 5 and 3, that will be adding 5 and 3. 5 and 3 plus 5 and 3 equals 8, and that age will be assigned to this variable 8. This add value of this 8 body part will be assigned to this add variable here, add as a result. And system.out.println add.compute, finally computational part will return, and then the value of that add will be assigned here, and the output will be 8 here. Similarly, the output will be 8 here. Yeah. Now, why we use this lambda expression? Why we use this lambda expression? There are various advantages and disadvantages. To state the advantages, we have more. We have here. It makes the whole programming more concise than anonymous inner classes. It says that it's more concise than anonymous inner classes. That improves readability and clarity. It will improve us readability and clarity, and it enables functional style. It enables functional style operations and collections. It will enable functional style operations and collections. So we can state that this cons- conciseness. Yeah, coming on to this, it will make the whole program very much concise. No more bulky anonymous classes or short piece of behavior. We have no more bulky anonymous classes for short pieces of behavior, and the readability for the readability, the intention of the code stands out clarity. We can understand the code very much clearly, and decorative style for the decorative styles we express that we want what we want to be done, and leaving a how we are underlying we have now leaving to how the underlying API. Using the API, we following the decorative part and finally getting the result. Now this lambda expressions powers has many modern Java features. They have many modern Java features like stream API for processing calculations, for processing collections, event handling, and graphical user interface code, and asynchronous callbacks in concurrency utilities. Mastering them with will make our Java code more expressive and maintainable. So so we use this Java. So we use this lambdas in our Java classes, Java functions. Now coming on to the summary, we have studied about the lambdas. They make the functions. They make the whole thing very much concise functions. They will have concise functions, and they must be in functional interfaces. They must be used with functional interfaces for providing it more concise part. We use these functional interfaces, and they're great for writing short. They're great for writing short functional style code, which will make our graphical user interface more attractive and dynamic. Now coming to the end, during this class, we will meet in the next class. Thanks.